the one piece of career advice that you wish somebody had given you when you were starting out?
So I think one of the most valuable things that I've learned on my career that I wish I'd known when I was starting was not to be afraid to fail and to make mistakes. I think failure is a really great learning opportunity. It really helps you to hone your craft. I'm a big proponent for craft and the principles of craftspersonship and software engineering. And I think one of the most useful tools, and you'll hear people say it a lot, fail fast. It isn't just a buzzword. It is really important to fail. It gives you two things. First of all, it makes you unafraid to make a move and do something. Often, I've got engineers on my teams today where they'll be hesitating to do something because they're worried about failing. And the answer to that is don't not act because you're afraid of failing. As long as you're acting in good faith, as long as you think you're doing the right thing, then there's nothing wrong with that. If you do make a mistake, own the mistake, put your hand up and own that mistake, but also take something away so that you don't make that mistake again and use it to hone your craft and change your ways of working. Something I do outside of software engineering is sewing. I've been doing it for 2 years and I've been doing it at the same kind of rate as my partner. I'm a lot better at sewing than my partner. My partner asks me, how come you're so much better? And the reason is I make lots of mistakes. I try lots of different approaches and learn from those mistakes. When you make a mistake in sewing, you've got to sit and unpick. It takes a long time, and the pain of that unpicking and sewing and fixing that mistake means that I don't make that mistake next time. I find a better way of doing the thing I'm trying to do. The same principle goes for anything in software engineering. If you make a mistake and it takes you a while to fix that mistake, you're going to be sure to not make that mistake again.
Can you share a pivotal moment in your career journey that's made a significant impact?
Yeah, I think the single most impactful thing in my career as a software engineer was working alongside exceptional people. So I got a really great opportunity once to work at the BBC. The one thing I can say about the BBC is they have great engineers. They attract, because they're such a global name, they attract really great engineers. And it was an accelerator for me in my career. The thing that really accelerated me, though, was transitioning from, I guess, regular software developing, regular software engineering to test-driven development. When I switched to test-driven development, it really accelerated my pace of coding. It accelerated my understanding of coding. At that point, I'd probably been coding professionally for around 8 years. I'd been around a while, but it absolutely leveled me up. So I'd highly recommend, if somebody's starting out, to begin with, it is more difficult to do than regular software engineering. And some people will say, well, it's no different to writing tests at the end. It is different. It helps shape the code that you're writing, gives you a better understanding of the code that you're writing. And when you get good at it, you will end up writing less code as a result. A good example of why I think TDD really impacted my ability to code is I use it today as a coaching and a training technique. I regularly teach people software engineering. When I coach people in software engineering, it's not people that already know how to do it. It tends to be people that have zero experience in software engineering. I use test first approach, TDD, to teach them software engineering. They very quickly grasp the basics of software engineering, but over a much short period of time, it's been my experience that they understand it better. And a good example of this that I have is when I teach somebody software engineering, I don't want them their whole approach to be my flavor of software engineering. So I often ask people on my team, will you do me a favor? I've got this person that I'm coaching. I wouldn't mind them getting an alternate view on different ways of working. Would you mind coaching with them? And I actually got a lead at my last place to sit and coach. And then I caught up with the engineer that I was teaching afterwards in a separate session. I wasn't on that session. I'll let them pair together. I caught up with that engineer that I was coaching, and we went through the code. And I said, "Oh, you've changed the structure here. Why have you changed that? That doesn't, it doesn't feel like a natural change. It feels it almost feels like a mistake. You've changed the intent and you're having to change the structure of all the components and the layers. The way it was structured to begin with worked really well. And this, well, I thought that because changing it that way made it really difficult to test. You'd have to go back and rewrite all the different components. But, he's more experienced than I am. In my opinion, the person that had been coding for 6 months had a much better grasp on this problem, and it's because it's the only way then you have to solve it. And actually, the solution that they proposed, that the lead had kind of poo-pooed, was a better solution. And it's because they've only known this way of writing code. They were writing better code, and they understood the code better than the lead did. And this was a lead on my team, and it was an eye-opening experience, I think. So, yeah, if you the single most impactful thing was learning TDD, and actually from TDD I actually learned some other software engineering principles that previously I would have said, oh yeah, no, like the solid principles. Before I really knew TDD, when I thought I knew TDD, I thought I knew the solid principles, but in practicing TDD it almost makes you learn the solid principles from first principles. It's like you're deriving them again yourself. If you do TDD well, then one of the outcomes of doing TDD well is it almost forces you to do the solid principles, because if you don't, you end up writing really big complicated tests, or your systems are difficult to test, so you naturally lean towards implementing the solid principles. And so now I would say I have an understanding, I grok the solid principles rather than knowing what they are, and I got all that from practicing TDD.
How do you approach challenges and setbacks in your professional life, and what's your go-to strategy for overcoming them?
So for this, I'm going to answer it from the perspective of a software engineer rather than an engineering leader. The approach I found most useful is collaboration. No man's an island. You've got a certain set of experiences that you can lean into to solve a problem. And that's finite. When you reach out and collaborate with someone else, they've got a set of experiences that can only complement your set of experiences. An example I have of this is when I was working at the BBC, I was working on their BBC iPlayer app for the Xbox 360, which is a bit like essentially Netflix, but the BBC version of Netflix. The framework on the Xbox 360, when you built a UI, every element on the UI, or certain elements on the UI, could receive focus. And as you interact with the controller, the idea is the focus moves around the screen. The particular framework that they had built, for any given element that could receive focus, you had to tell it declaratively, if I push up, this thing receives focus. If I push right, this thing receives focus. The challenge there is when you're building an application, you don't know what the UI is going to look like, and you want to change the UI. As you move things around, where you press right now and something receives focus that you wouldn't expect to receive focus. And it's very manual, very time consuming, and prone to mistakes as you move the UI around. So we had a ticket. I picked up a ticket that was to just make it essentially generic. When something is in focus and you push right, find the thing in the screen that is on the right that should receive focus and give it focus. And we did this. Obviously, we had a commitment to test-driven development. It's quite a difficult thing to do when you're not running the code on the Xbox. So I had experience in the particular technology that was used to build the UI. It was called XAML. But I didn't really know about what is essentially hit detection, right? Like in video games, hit detection. One of the other engineers on the team had no experience in XAML. Had been working on the project for maybe 3 months, but didn't have in-depth experience of XAML. But he was a video games developer. He knew all about hit detection. So on my own, I would have come up with a suboptimal solution. On his own, he would have come up with a suboptimal solution. Instead, we paired together, and the solution that came out of it, we got to it quicker than if we'd have worked on it on our own. And it was a much better, much more elegant solution because it lent into both of our strengths to produce that solution. I got there by collaborating. Had I sat and tried to work that problem on my own, I wouldn't have come up with the same solution, and neither would he. So I often use it as an example. Sometimes software engineers, when you suggest collaborating, can feel like you're suggesting that, oh, maybe they're not good enough to do their job. That's not what I mean when I suggest people collaborate. What I mean is maybe by working with someone else with a different set of experiences, you can come to a much stronger solution in a much shorter time by leaning on your strengths and leaning on theirs.
How do you balance velocity over quality?
So a lot of places that I've worked, including the place I was at last, you try to use velocity as a way of measuring the performance of a team, so that they equate it to the pace of the team. And it's understandable, because the term velocity, generally you understand as meaning the speed of something, but it's a really ineffective measure, and it's also, in my opinion, a toxic measure. And the reason is, if you've got two teams and they've got a notion of how they size tickets, what one team will size as a 2-point, another team may size as a 5-point, and as a result, I can't look at two velocities of two different teams and compare them. They don't add up. So that's first of all, it's not good for that. So you may say, okay, well, let me look at each team individually. I don't care that their measure of velocity is different for team A than it is for team B, but what I would like to do is, let's make team A go quicker. And the challenge there is that the measure of the points, the estimation of those tickets, comes from within the team. So if you say to a team, you're doing great, I just need you to go quicker, let's get more velocity out, the team go, right, okay, and they game the system. So what previously they may have gone, well, that's a 2-point, but we need the more velocity, and they naturally say, well, that's a 5. And what was a 5 might become an 8, and what was an 8 might become a 13. So they're getting through more points in a sprint. They're doing the same amount of work, but they're getting through more points. So their velocity goes up, but their pace does not. They're not getting through any more work than they were previously. And what happens then is, because their velocity is going up and up and up, but it's not really going up and up, their velocity looks like it's doing this, it's just out of control. They now lose the ability to know what their actual capacity is, which is what velocity is really a measure of. It's a measure of what is the capacity of the team. And as a result, it becomes really difficult for the team to predict what they're capable of working on, how much work they're capable of getting through, and they end up with a really poor planning accuracy, and performance looks like it actually gets worse. So instead, I use what's called the DORA metrics. So I think back in 2016, some researchers went off and did some research around various engineering organizations, various engineering organizations, lots of teams, lots of repositories, code repositories for those teams, and lots of commits for those teams. And they looked at the good teams and the bad teams, what was thought to be good and bad, and they looked at various different metrics, and they came out with 4 metrics that they correlated to good performing teams. And these four metrics, there are 2 around pace and there are 2 around quality. The 2 around pace are the lead time per change and the deployment frequency. So lead time per change is the amount of time between an engineer picking up a ticket and then that change being in production. And then the deployment frequency is how many times per week is the team deploying something. So they're around pace, but a team could game those. They could just absolutely just chuck code out. It could be terrible quality. So whilst they may be hitting those pace metrics, not in the quality metrics, so you can balance those with the 2 of these DORA metrics. The 2 other metrics are change failure rate and mean time to restore. So the change failure rate is for every deployment that I make, every change that I make in the application, how many in 100 changes results in a failure in production. And then mean time to restore is when there is an issue in production, how quickly can your team remove that impediment. So whether that's getting a fix out, or maybe it's your features sit behind feature toggles and you toggle it off, whatever that is, how long can you restore normal services? And so these are quality measures. So on their own, the pace measures aren't sufficient and the quality measures aren't sufficient, but as long as you balance them, you get what this group refer to as an elite software engineering team. So every year Google repeats this research. They re-look at what is the current state, and they repeat what's called the DevOps research assessment. They re-look at lots of engineering organizations, lots of code repositories, lots of commits. They plot the lead time for change, the deployment frequencies, the change failure rate, and the mean time to restore on a graph. They divide it into 4. And if you're at the top end of the graph, you're an elite team. If they're at the bottom end of the graph, you need some support. And there are tools that you can use that look at the commits that your team are making and the tickets that they're progressing through to figure out where your team kind of lies on this spectrum across these 4 key metrics. So we use a tool, the actual tools that we use is called Linear B, but there are other tools that looks at that on an individual engineer levels, individual pieces of work level, at the team level. You can look at it at project level. And I found I started using this for the first time at the last place. When we start looking at these metrics, at the lead time for change, and what they refer to at Linear B as the protometrics that influence those. So, for example, if you've got a really large lead time per change, it's really difficult for me to say to an engineering team, get that down, make that smaller. But what you can say is concentrate on the PR size, try optimizing for a smaller PR size, and in doing that, the lead time for change naturally gets smaller, and as a result, you start getting a greater deployment frequency, and then you can work on the quality metrics, and there are certain practices you can do there. But it's a really good tool set, not for making, not for having a stick to beat the team with, but for having conversations, for spotting issues. We use it internally. I use it where I am now. I use it at the previous place. We found it a really effective tool to identify when there are issues in a team, preventing them from delivering successfully, so that we can investigate, take action, resolve those, and then get the team back on track.